And that's really the most exciting part about it. Um, it's got some interesting uses. Um, I think the things that a lot of ham radio operators are intrigued about it are that it can both communicate in full channel broadcasts. It can do private messaging, encrypted, as well as user to user single messaging. So that, in emergency scenarios, you're able to broadcast out to any device who can receive a message. Um, in more like community spaces, it's a great way for groups of people, say in rural communities, teams working and moving off grid, to communicate both, again, broadcasting out to anyone, communicating in private forms, and sharing GPS location, and then again, just recreation in scenarios where the average unlicensed radio operator, um, running an FRS walkie-talkie would maybe get a mile of distance. These LoRa mesh radios are going to get you multiple miles of distance, and since they mesh together, you can really expand your coverage, whether you're just a small group moving around in the woods on a mountain, or adding another radio into your mesh that acts as a repeater. So yeah, off grid. This requires no satellite. Every radio in the mesh creates the grid. It's encrypted, and because it is a licenseless um, mode of communication, it's also free. So, kind of more technicals. LoRa, long range over radio. Pretty simple. The difference here with Meshtastic and these mesh radios, for those who are unfamiliar, is that they are not voice communication. They are a data packet. So it's text message communication. And the LoRa architecture was originally created for data transmission on the 915 megahertz ISM band. So IoT data transmission, command and control of electronics. Um, but some smart guys have figured out a way to use it for communications. So in the data packet sent on in the different protocols, you're going to get your text message, and then you're going to get typically radio telemetry, which will include like GPS location if you choose to share that. The name or call sign of the device sending that message, as well as just some other metrics, signal strength, battery health, that type of stuff. So again, it is a data packet. It's about 230 characters of text message, and it's about uh, one kilobit of speed between the devices. So again, the beauty of the 915 megahertz ISM band, is that it's free for anyone to use. No license required. You are allowed to encrypt your messaging, and that is a pretty standard function of most of the calls that do communication on the 915 megahertz band, as long as you are not operating above 1 watt. So these are very low power devices, and it's really interesting that we're getting miles of range device to device. And then when you add some higher gain antennas into your mesh, you can really get some very significant range. Being decentralized, you guys, ham radio operators absolutely understand that there's no one maintaining the network besides the user. No towers or routers are required. However, people are setting these up and maintaining them themselves. Every radio is a transceiver and a repeater. And then again, as I mentioned, there's three main communication types. You've got your public broadcasting, meaning any mesh radio running the same protocol can receive the message when you broadcast publicly. You can establish private channels, which are encrypted, and you have to have the encryption key to be able to decode and read the message in that channel, as well as user to user, like single, like simplex type private messaging, where again there's a kind of an automatic handshake that happens between the devices to pass the encryption key and keep your messaging private. So yeah, I always like to show a little diagram here of your kind of centralized and decentralized networks. The average person is familiar with cellular, satellite, and standard Wi-Fi being centralized, where you've got at least one tower, router that is the hub for all the devices that are communicating. Very simple, very similar to uh, um, how ham radio operators communicate on a repeater. You're communicating through the repeater. Your transmission goes to the repeater and then goes back to the people listening on the repeater. More decentralized, where these mesh radios operate, is where uh, you do not need to be able to communicate with these larger hubs, repeaters, directly, because your message can hop across other devices that are in between you and say a repeater or a router that's identified in the mesh. So it allows your message to bounce around, to potentially get a lot further and get to radios that you yourself cannot communicate directly, line of sight, say like via simplex. Um, but again, your message can hop across multiple devices to either broadcast out to a lot of people or to get to a specific radio that you're trying to communicate with. So there are quite a few different mesh protocols, and Meshtastic just happens to be the most popular. There are two other ones really of note, that I was always like to inform people about, Reticulum and MeshCore. If you're a if you do anything in computer networking, IT, check out Reticulum. It does some really cool things, that any type of IT computer networking guy would be really excited about. And then MeshCore has kind of come up as a competitor to Meshtastic. Um, it's a smaller group running that project, but they're really advancing it quickly. Some of the past mesh protocols that have been out there, there's one called Disaster Radio that was an open source project. There was another one called Gotenna. Again, similar mesh radio architecture, but it was closed sourced, and you ran on the same 915 megahertz band. They started as a consumer product, with a subscription, I believe. And then over the years, they got some military contracts and actually shut down their consumer side of the business. Um, and we'll briefly talk about this towards the end of my little presentation. But Spec 5 is working on our own closed source protocol called HyperMesh. Um, it's going to offer a lot of the same functionality as Meshtastic. We will have like a public branch, um, for for hobbyists and enthusiasts to use. But it's really going to allow us as a business to have have our own protocol and do customizations for customers, mainly in the commercial and government sector. So, Meshtastic, it's supported a few different ways. Your radio is going to typically need to connect to, I'll call it a companion device, or as the military calls it, an EUD, end user device. So a phone, computer, or tablet. Um, so you've got all your standard support for Android, iPhone. There is a web-based client so that you can connect a radio just to a PC, as well as Linux and Python again for your real IT techie types. And most recently, the Meshtastic project has released what they call the Meshtastic UI, which allows some devices to be fully standalone. And we'll get into that a little bit in the next slides. So yeah, just another picture kind of highlighting how the devices mesh together. So um, up on top here, we've got two radios that just have a screen and a couple buttons. So these radios on the left is our Trekker Bravo, and on the right is our Beacon. Again, both of these radios do not have a keyboard, so they are simply like your router into the mesh, and you have to Bluetooth your phone to this radio, run the Meshtastic app on your phone, and the phone becomes your user interface. On the bottom of the screen here in tan, we have a Ranger, which looks very much like a BlackBerry. This device runs the Meshtastic MUI. So this allows you to have a fully standalone device. It has a full UI. You can set the parameters of the device. You can do messaging. You can see what's called your nodes list, which is the full history of all the other Meshtastic devices that your radio has communicated with, and do all your various channel broadcast and private messaging, as well as having a full map on that device, so you can see all the nodes in your area that are sharing their GPS location. And again, as I mentioned, all these devices can be connected to over Bluetooth, as well as USB serial to a computer. Some of these devices also allow a Wi-Fi connection back to a computer or back to the internet, which will get you a little bit greater range between the radio itself and the user interface. And again, they mesh together using LoRa. A couple great resources, especially for new Meshtastic users. Always like to show the Meshtastic website. When you come to the main website, if you click getting started, they've got a pretty decent like Wikipedia style page put together. If you're really looking in getting into the nitty gritty of how to buy, how to start from scratch, flashing your own firmware, configuring the device. There's lots of great information here. They've got some recommended devices. There's a lot of information on the different software and apps, and the UI, and the again, different settings. So I highly recommend, if this is something that you're getting into, spending some time going through this, because there's a lot of great info. But also it can also be like drinking from a fire hose. And we totally understand that. I'll get back to my presentation here. There are two different node maps. I think a lot of people, I get a lot of questions from customers asking, like, how do I find out if there are Meshtastic users in my area? And unfortunately, this is a really hard question to answer. There are two different node maps. There's meshmap.net, and then there's this Meshtastic node map that this guy Liam Cottle has put together. And unfortunately, I would say on both of these maps, like 10 to 20% of the actual nodes, say in the US or greater, are displayed on these maps. And the reason for that is because you have to, for these maps to populate, you have to have a handful of nodes or radios in the mesh, not just connected to the mesh, but also connected to the internet. And then once they're connected to the internet, they have to be set up to forward their mesh data to one of these mapping services. And you just don't see a lot of that. So in some areas, you've got Meshtastic users who have a radio maybe mounted on their house, permanently mounted in their office, um, connected to the internet and transmitting that data to populate nodes on these internet-based maps for kind of the world to see. Um, and so it's kind of hard to get a good vibe of how many nodes are going to be in your area. Now, in greater metropolitan areas, you're going to see more node information on these maps, but kind of further out of the main hubs of your state, you're gonna see just about nothing. And honestly, the best way to find out what other Meshtastic users are in your area, unfortunately, is to buy a radio, turn it on, and drive around with it. I was actually in Colorado 2 weeks ago. I flew into Denver and then drove down to Colorado Springs, specifically Fort Carson, and I had my personal Ranger on, sitting on the dashboard of the rental car as I drove from the airport down to Colorado Springs, and I was able to see probably about 20 or 30 nodes in the Denver area, and then even probably like 10 to 15 in the Colorado Springs area. So there are Meshtastic users out there. Uh, the other resource for finding local Meshtastic users is going to be the Meshtastic Discord. Um, it's huge. There's so many people on it, but they do have sections by region and by state. And from there, there are a lot of like subgroups. I'm located about 45 minutes to an hour outside of Austin, Texas. There is an Austin Mesh Discord server. Um, I was down in Florida earlier in the year, and for Hamcation, and I met a bunch of Meshtastic users, and they have a Florida Mesh Discord server, and they've got like 800 people all over the state of Florida on that. I haven't checked to see if there's one for Colorado. I wouldn't be surprised if there is. So definitely check that out. And then the last resource is what's called the Meshtastic Site Planner. And that's the image here on the right side of the screen. It allows you, and again, a lot of you ham radio guys have probably used similar mapping tools where you can go and see what your transmission um, profiles look like from a point. So this is actually me putting a Meshtastic device 7 meters off the ground at my house. Um, this is where I can reliably transmit and receive to and from, um, the 915 megahertz band and a lot of other um, ham radio bands rely heavily on line of sight. So this kind of shows the topography near me and around me. in my signal strength as it goes out across the lands in the Texas Hill Country. So that's kind of like the main topics that I like to hit on like Meshtastic, getting started, and where to look for more information. Spec 5 is a company. We're building both software and hardware to make these mesh networks an instant on experience for our customers. So the radios come pre-programmed, obviously pre-assembled, and just ready to use out of the box. So as I kind of mentioned earlier, there's a lot of different configurations to the devices themselves. Um, we've kind of got like two main classes of devices. You got your handhelds, and then I like to call the rest like a companion device. Um, we talked about the Beacon, the Trekker Bravo earlier. These are just different size handheld devices. The Beacon can also kind of be used as a beacon. It's not fully waterproof, but it's something that can be left behind, and operate and repeat signals for multiple days. And it's got a small solar panel on it, just to kind of continue extending the battery life. But it's still small enough that you could carry it, flip to your bag, um, or kit. The Ranger we talked about is your BlackBerry device that has the full UI, so you do not need to connect this device to the phone into the Meshtastic app, um, to be on the mesh and use the mesh. And then we've got some small, like our smallest device is the mini Trekker. Same functionality as the Trekker Bravo, but much smaller battery and an internal antenna. So you're gonna get a couple hours of battery life out of it, and your range is gonna be reduced. But in areas where your mesh is dense and there are a lot of other radios, you really don't need lots of transmit power, to still communicate in the mesh. Some other more interesting devices. I'm gonna start with the Spectre. So this we created a all-in-one device. It's very small. It's actually a mini Android phone, that we have added the LoRa mesh radio to. That's a 2.5-inch screen, so it is tiny. It is even smaller than like the original iPhone. But just small form factor, all-in-one device, because again, it does run the Meshtastic app itself. Um, so for the user looking to kind of have a full off-grid device, not having to carry an extra phone around, not having to carry a phone that is tied back to Wi-Fi, your cellular networks, the Spectre is an option there, and we're actually working on a Spectre 2, which has a larger phone, and then that will also have the ability to have a SIM card, if you want a backup device. Our Pulse Pack is an interesting product because we actually combined an FRS radio with a mesh radio, so it gives you short range FRS voice comms, again, licenseless, with the Meshtastic radio, in one device, so that you also have kind of a longer range text message communication and GPS location sharing. So we've seen some interesting uses for the Pulse Pack, just in like team communication, people out in the woods, and it gives interest, very, very versatile, like mixed mode communication for people who do not carry any form of license. Utility Trekker is another product. It's our one handheld radio that adds some sensor technology, and we're actually working on a couple new devices that are going to have more sensor technology. But this one, the utility tracker, has a temperature, pressure, and humidity sensor in it. So that data is just automatically broadcasted on the mesh. The last device here is the Spec 5 Nomad, and we actually just relaunched a updated version of this. This is a full handheld Linux computer. So it has a Raspberry Pi inside, um, with full keyboard, touchscreen, power management, so you can be fully wireless, moving around with the Nomad, or on a desk. And it has a LoRa radio standard, and it has an option to actually add a software-defined radio. So the idea here for the Nomad is very like the super user type, someone who wants to do some of the more advanced functionality in Meshtastic, which really does require Linux, and or as we like to call it, some kind of base level electronic warfare type operation where you're actually scanning frequencies, maybe with the SDR, maybe doing drone detection, maybe doing Wi-Fi or Bluetooth sniffing. Obviously, all under the appropriate legal parameters for doing those things. And then we kind of move on to what I like to call companion devices. So I think the most interesting one here is the S5 Copilot. And what the Copilot is a mesh radio that you install on a drone. And what does that give you? That gives you a loitering tower, a low orbit satellite, as I like to call it. If the average person can't put up a tower in a repeater at 400 feet AGL, but you can legally fly a drone up to 400 feet, and most small drones can hover in place for 20 to 30 minutes, depending on the wind. And you can greatly increase your range of transmission on Meshtastic. When I put a drone up, I can typically reach 40 to 60 miles, depending on topography. Obviously, Texas is a lot flatter than Colorado is, but it's really interesting. It's a really interesting use case because this, in certain scenarios, adding a mesh radio to a drone might be the only way that someone in Colorado could get a message over a mountain, over a significant topography, or even in a city over and around buildings. So it's a really great way to extend the mesh. We've also got the Spec 5 Voyager. Voyager is kind of the set it and forget it radio for your car. Full large solar panel, magnetic mount. So sorry if you have an aluminum car or a plastic roof car, it will not work. On that, you need good old proper steel. But it's just a battery and solar operated mesh radio that you can leave on the roof of your vehicle 24/7, and then Bluetooth your phone to it from inside the car, and have comms on the go. And then the last device is our Trace. We actually just launched a new model of it that has an external antenna instead of the one in the picture shown as an internal antenna. But the main use case for the Trace is using these mesh radios specifically for GPS tracking. Your standard Meshtastic device outputs its GPS location typically every 15 to 30 minutes, if you are sharing your GPS location. The Trace, we've created a very small waterproof device that we have adjusted the parameters so it is always outputting its location every 30 seconds. So our initial use case was for tracking dogs. but we've also created an external antenna version, that can be strapped on a backpack or like a tactical vest, any kind of like Molly mount, for tracking teams. Um, Out off grid. But again, the radio hardware is all the same, so it still can be, you can still Bluetooth connect to it and use it as a communication device and not just a tracking device. So it kind of gives you this dual use um, functionality. And then the last device, which I think most ham radio operators are going to be most interested in, is like your fixed position radio repeater. We call it the relay. Um, It's actually a very simple device. It is a normal mesh radio with a battery and a very large solar panel and a big antenna. And that's really all it needs to be. It is simply just another radio in the mesh. This one is just standalone. You strap it to a pole or mast. It does not need any power because it is self-sustaining. The battery alone will run for like 5 to maybe even 12 days, depending on message traffic. Um, and then the solar panel is greatly oversized. Even on a very cloudy day here in Texas, the solar panel, the 12-watt solar panel, or sorry, 10-watt solar panel, is outputting enough juice to maintain the battery in the radio housing. And then we've got a nice large high gain fiberglass antenna um, that again really extends the mesh. We've got I would say most of our users, if they can get the relays antenna up above the tree line, they can typically get 30-ish miles of range out of a relay. People that have really good line of sight are going to get probably 60 to 100 miles range. We have a ham radio group here in northeast Texas, who are Aries and Skywarn, and they do a whole bunch of other things. I always forget the list of all the different protocols and programs that they support. But they have been installing relays on all of their repeater sites. And they have one relay up at 600 feet, and they can see other mesh radios about 130 miles away. And again, these are all sub 1 watt radios. So the technology is really cool. And as you guys know, height is might. A few other things that Spec 5 is doing, we've actually built a handful of game apps. And these are free for anyone. They're out on the Google Play Store. So if you're a Meshtastic user who uses an Android, you can play these games. Unfortunately, the Apple iOS App Store has a much longer approval process, so bear with us on that. Basically, these apps run over Meshtastic. So instead of just sending a text message, when you link two devices together um, over the mesh, over the 915 megahertz band, when you make moves in the game app, it sends a message across the mesh, and then your opponent sees your move, and vice versa. So we've got tic-tac-toe, checkers, chess, and then I think we're also working on like the old school, like Gorilla Goes Bananas game, where the gorillas throw the bananas across the cityscape. Good old MS-DOS game. Um, so yeah, these are just kind of our ways to um, get our software development team learning other, I'll call it useful uses for this type of mesh radio protocol. So in the future, we're going to be able to kind of do some higher level software functionality on top of Meshtastic. for custom apps for customers, and hopefully other functionality that we can offer to the public as well. And then last, I briefly spoke of it, is HyperMesh. This is our own mesh protocol that we're working on. We're really currently optimizing it for like small group communication. This is not going to be something set up for like public broadcasting like Meshtastic is. And we're going to be adding just other functionality that's different, different no app modes, so that you're not limited by your handheld device, for different laptops, handhelds, and phones, and then again, because we own it, we'll be able to do customizations for customers, as well as um, adding like sensor functionality for data collection. And we also plan to do like command and control, so that over the mesh network, you can actually control devices, turn on and off lights, warning buzzers, hell, maybe even control your garage door over the mesh. So that's kind of my quick rundown on mesh devices, and what Spec 5 is working on. We do have a little $5 off coupon code that works on our website, just Spec 5 all in caps. And from here, I kind of just like to open it up for questions.
Hi, Greg Ella here, N0EMP, one of the NCARC board members. So we've got repeaters in the area at remote sites that are all linked with private microwave linking. When a site goes down, we lose that link to that site, and we can't find out what's going on up there without driving up or hiking up or snowshoeing up in the winter. So I've been looking for a back channel way to get telemetry out, like 4 or 5 different voltages, maybe inside and outside temperature. And I've been looking for a plug and play, ready to go device that would be an interface, maybe Arduino based or something like that, to, to take several voltages and report them through Meshtastic. Is there anything out yet that does that? That's just off the shelf.
Off the shelf, no. We are actually working on that specific use case, having a like small microcontroller type device that can collect multiple data streams, multiple sensors. So just as you were saying, temperature, multiple voltages, and if any of your radio equipment have any type of other like I squared C SPI type bus, you'd be able to read that signal, um, turn that into a message data packet, and then hand that off to the mesh radio to disperse that message on the mesh. Um, so that's something that we're actually actively working on, not for your specific use case, but just in a general data transmission use case. The project that we're actually working on, that's kind of specific to Texas, is a flood gauge that runs on the Meshtastic protocol. So we are, we've got a couple different options for sensing the level of the river. When that sensor gets tripped, the microcontroller will both set off an alarm on the device, as well as hand off that alert to the mesh radio to then share that message that, hey, this flood sensor at this location has triggered an alarm, and then other flood sensors downriver or in the local area would then be able to also trigger their alarms, and off receiving that message from the first sensor that was tripped. Um, so yeah, that's something that again we are actively working on. I've actually got a local county office of emergency management that's literally looking to do the same thing as you. They've got a repeater site with some radio equipment in it, and they run into the issue where uh, the power goes out, the repeaters are running on a backup battery, but here in Texas it gets hot and the repeaters overheat, and they have no way of knowing what's going on inside that repeater station. So we're working on a specific mesh repeater that has external sensors that they can route into the building and have live temperature monitoring. So nothing off the shelf yet, but that specific use case is coming down the pipeline.
Did you get one? Anybody else have a question?
In your experience, what's the greatest distance in overland that you've had a successful connection that you're aware of? And have you had much interstate connection?
Well, unfortunately, Texas is huge, so that's a problem, and I live right in the middle of it. Last fall, we hosted an event called MeshCon, and we launched a Meshtastic device on a balloon. The balloon went up like 8 or 9 miles, and we were still able to connect to it from the ground. Um, and so we launched it in Central Texas, just north of Austin, and we were able to connect to nodes in Houston, which is like almost 200 miles away, as well as Dallas, which again is like almost 200 miles away. And Dallas, Austin, and Houston were all able to talk to each other. We've seen mesh radio users in like the plains, like in Iowa, where it's super flat. They've been able to go 130 miles, like direct node to node. Again, line of sight is key there. Um, I personally, I live about 60 miles outside of Austin. My little home Meshtastic repeater is down right now for some repair. But when I get it back up, I kind of live up on top of a hill. I can hit another Meshtastic repeater that's about 30 miles away. And then from that repeater, I can hop the other 30 miles into downtown Austin. Um, and there's a handful of repeaters. There's one at like University of Texas, and then there's a ham radio club in Austin that they have a Meshtastic repeater set up, and I can then receive message traffic from the city from in happening in the city. So yeah, there are some really impressive range capability. And then on the flip side, you can be in a hole and you can't go more than a mile, So I think you guys understand that type of variation in range the most.
Is there any way the FCC might get involved in trying to control the frequencies for one reason or another? Or are they always going to be able to do what you're talking about now? In other words, can
Yeah,
somebody come in and blow you out of the water because they're not going to let you do what you're setting up to do?
yeah. So the 915 megahertz band, which actually goes from like 903 to 928 megahertz, is an FCC allocated band specifically for instrumentation and measurement, I think is what they call it. So Internet of Things, IoT devices. So it is by the FCC in unregulated band, or open band rather. I think that's the better use for it. As long as you're operating under 1 watt. Um, so I believe there are commercial applications that can apply to operate on those frequencies over 1 watt. And then ham radio operators can also operate over 1 watt on those bands. However, that kind of changes things for Meshtastic, because then technically you can no longer encrypt your messages, because ham radio operators cannot encrypt their communications. So yeah, I don't see that being a big issue. I do know that you know, we all kind of see on the news where different technologies are trying to you know, reallocate some of these band spaces. But Meshtastic, and these other mesh communication protocols, and there's a handful of, you know, LoRa based 915 megahertz based, like IoT and just like data transmission protocols out there as well. They're just very popular and very widely used. And I think it would a lot of people would put up a big fight if some you know, commercial entity or government entity tried to reallocate these bands, because they are pretty widely used. So yeah, I don't foresee that being a problem.
Daniel, thank you so much for being here. Appreciate it. I think you've explained everything to us that we ever want to know about Meshtastic. Thank you so much for that.
All right, excellent. I'm glad to be here. You know, I think the ham radio community has been a really big help to us at Spec 5, both understanding the space and understanding how, you know, how radio operators are using many different types of communication protocol, and what the purpose is. So I myself just got my technician license about 2 or 3 weeks ago. So I'm super excited to officially be a ham radio operator now. But you know, I really appreciate the hobby and the craft, and I've just met so many like really nice people that are just wanna be helpful and use their radio to do it. So thank you guys.
Hope to catch you on the air then. Thank you.
Absolutely. Thank you so much.
This presentation was brought to you by the Northern Colorado Amateur Radio Club. For more information, visit our website, ncarc.net. Thanks for watching, and don't forget to like and subscribe.